Hello and welcome. Today we're going to be coding an ultrasound program. So we're going to take in some wave data. We're going to encode it into bits or numbers here, and then we're going to write a program that turns it into an image that you see over here. Not only are you going to be able to take in medical data and show the problem with the kidney stone, but you're going to be able to create your own images and send them to other people so they can use their programs to decode your fun secret messages. Okay, so this is what the final program looks like. We're going to start all the way at the beginning and show you how to get here. All right, so let's take a look. Over here, I've got a blank copy of this program, but let's go even further to the back and think about what we're actually going to start doing here. So, medical imaging, ultrasound, we take in two different kinds of data. The two different kinds of data we take in are first, the time it takes for the wave to return. So the type of data we take in with echolocation is we get the time it takes for the wave to return, okay? And then our computer turns that into the location of a pixel, all right, which is one of those little boxes you saw earlier on the image. But we also get a different kind of data from what kind of material it hit. If it hit a more dense material, we're going to encode it as a bright pixel because we see a larger amplitude wave. If we see a shorter amplitude wave, we know it reflected off of a less dense material. So we can also show that as the brightness of the pixel. Okay, so what does this look like in practice? Well, if we take some data that we receive from our ultrasound device, these are like electrical signals, and you see here, our computer is reading. It doesn't see any waves right here. So look, we write all zeros right there. The computer writes all zeros, and as we progress, we are still reading some waves. At this time, we don't see any waves. And then boom, look, we just saw a bunch of waves. They're all encoded as line 1 because they're small amplitude waves. And then so on and so forth. We continue. We don't see anything inside of the kidney because it's not reflecting off of anything. And then as we continue forwards, we start to build out our image, okay? And so eventually we see that kidney stone in the center, that bigger wave in the center gets turned into a bigger number, and eventually it gets turned into an image which looks just like this. Now this is a really low resolution image, of course. Real medical ultrasound technology has thousands and thousands of pixels, okay, so we can see in much greater detail, but this is the basic concept and it works exactly the same way. Pretty cool, right? Okay, so we're going to actually build some code that does this for us. So let's get started. Okay, looking at your blank spreadsheet, let's take some time to get this organized. Okay, so the first thing I'm going to do is I'm going to write down some constants over here. Actually, you know what? Let's get our cells organized. So our pixels should be roughly little squares. So if you click up here in the top left, you will get, you'll select all of the cells. So you look at all of the columns, all the rows get highlighted in blue. And then I'm going to lengthen out this just a little bit, lengthen out this. You'll notice all of the rows get taller, and if I shorten this, all of the columns get shorter. So I'm going to try to make them, I'm going to turn them into little squares. Just make that a little bit bigger. Okay, make that a little bit wider. Okay, and approximately until I get there, you know, approximately they're a square. Okay, good enough. Maybe I'll make that a little smaller. Okay. Yeah, let's make them small squares so we can actually fit everything. Okay, and then I'm going to click out. And now I'm going to go to this first row. I'm going to lengthen it out because this is actually going to be a place where we're going to write some words. The first words we're going to write are, I got to put in some constants. One of the constants we know is the speed of sound. Just write the speed of the wave. And then in this next cell, I'm going to write the number. Inside of the human body, we've got a speed of 20 centimeters per millisecond. So notice I put the number here. And then in units, I'm going to put it right here. cm per ms, centimeters per millisecond. Okay. Important we get that by itself in its own cell because we're going to grab it and do some math on it a little bit later. All right, and then down here is where I'm actually going to build out my image. So first up here, I'm going to write my line. So I've got line 1, and so on and so forth. 2, line 3, and these are like the piezoelectric crystals. These are the actual probe locations that are doing the echoing and the locating. Okay, so let's get all those lines set up. Line 6, get a nice space, make my program look good. Line 7 and line 8. Okay, and then I also want to know the time at which it was detected. So let's actually go down here. The time in milliseconds is going to be shown underneath. So right here, I'm going to left justify this so it come up to the top. I'm going to left justify this so it ends up over on the side. And then I'm going to measure in terms of 0.1 milliseconds. So I'm going to go 0.1. Next cell is 0.2, so on and so forth. We're just getting our image, our graph set up, basically. .6, 0.7, and 0.8. Now the next thing I'm going to do is I'm going to make this look a little bit more like a computer screen. So how to do that? Well, I'm going to select all of these cells, okay, and to make it look like some actual data collection, I am going to come up to the top here and look at this little window here. I can change this to borders, and then I'm going to select the solid borders for all of the cells. That's because data is going to go into each one of these little cells. A number is going to go into each one of these little cells. Then to make it look nice, I'm going to center all of the objects that are going to be in there, and I'm going to center across the middle too. Finally, to make it look really good and distinct, I'm going to choose like a pale yellow. You can choose whatever color you want. I'm going to go with pale yellow here. This is, if we look back over here, this is the received wave data, okay? So our computer is reading this and turning the little amplitudes into numbers. This is received wave data. Okay, and then I'm going to center this. Dude, now it looks nice. All right. So over here, this is where you're putting in your waves. So maybe you don't see anything at first. You know, this first line, we don't see anything, and then nothing here as well. Okay, but then we see a little blip end up there. 1, 1, 1, 1. So this is like the front wall of the kidney, for example. And then a 1 here. Inside of the kidney, we don't see reflections. So 0, 0, 0, 0, 0, 0, and 1. Okay? And I'll show you why I'm setting this up right now, actually. Okay, so we're just going to put in some data. So I put in some example data. This is not going to match what's on your paper, so you're going to have to go back and change this later. But let's just set this up to see what happens when I go over here. So when I go over here, I've got to set up my computer screen. So over here, in an 8x8 cell, so I'm going to count carefully. I got 1, 2, 3, 4, 5, 6, 7, 6, 7. I've got 8 now. Double check. 1, 2, 3, 4. 1, 2, 3, 4. Okay, good. Now I've got my computer screen over here. I'm going to do an outer borders. Oh, it doesn't want to do it. There we go. Okay, there's my computer screen. My image screen. Okay. The first thing I'm going to do is I'm going to calculate the depth that each of these waves are received at. So this is where the coding comes in. I've got a depth, and it's going to be listed out of the axis because remember, we're transforming this data. We're turning this from time data, time and signal data, into distance and brightness data. Okay. So how do we calculate the depth of something? Well, remember from our problem before, this is just an example. The depth equals that velocity times the time, and then all of that is going to get divided by 2. Remember why we divide by 2? It's because the time we get it is the distance there and back again. Okay, so depth equals velocity times time, all gets divided by 2. So let's actually do that in our code. Up here, we've got the speed of the wave is 20 centimeters per second, so that's our velocity. And then down here, I've got my time, and then I'm going to divide it by 2. So let's write in our equation. Double click, and then press equal sign. That starts us to coding. It's got some suggested code here. We're going to ignore that for right now. In parentheses, this is an important part. In parentheses, I'm going to put a $sign, and then I'm going to click my speed. And the reason I'm going to do that, oh, sorry. I'm going to put a $sign. I'm going to write the cell name. So I've got cell B1. Cell B1 is this cell that contains my speed. I'm going to close the parentheses. The reason I put the $sign is I'm going to do something cool called iterating, okay, and it's just going to grab that same value over again. So you need that $sign if you want to do it fast, okay? So I do multiply. I'm going to multiply by my time. This is the first piece, so B12. I'm going to close the paren. And then I've got to divide this whole thing by 2. Divide by 2. And then I'm going to hit enter. Boom. Automatically calculated that. Oh, let's put the units here, centimeters. There we go. Nice job, Mr. Hartley. Okay. Now, you see this little bubble here. The really cool thing I can do about this code is it knows, the computer knows, I've got a bunch of similar values because I set it up very carefully. I've got a bunch of similar values that could be multiplied and transferred over here. That's what we want to do. We don't want to have to write our code again. So if I extend it, look, it just did the same problem over for me again. If I double click the cell, it rewrote the code for me. It kept B1 the same because I put that $sign in front of it, but now it's C12 divided by 2. Okay, so let's do it for the whole row. I extend, release, and boom, look, it calculated all that stuff for me. Awesome possum. Okay, now we've got our depths calculated so we can see how deep the image goes. And now what we can do is I can select all of these cells, I can select a cell, hit equal sign, and what I want to do is I want the computer to know what's going on over here. So I click over here, all right? We got 0 data over here, so I'm going to enter. Okay, so it's just going to put a 0 there. I'm going to do the same thing. I'm going to iterate across all these rows, and it grabs the values from over here. And now what I'm going to do, iterate, and I'm going to iterate down. Watch what happens. And we just grab all that information. So we just put all that information over here. It's like, oh, great job, Mr. Hartley. You could have just written it again. Well, sure, but this is the goal of coding is to make things faster, right? So I'm going to get my borders back. Got my computer screen. All right, we're finally ready to transform this into an actual image. Here's how we do it. I'm going to select this whole computer screen, and I'm going to go up to Format. Now for formatting, I'm going to go to something called conditional formatting. Okay, so pause the video, make sure you can find that, conditional formatting. And now I'm going to select conditional formatting. I'm going to go to color scale. And I'm going to select a color scale. See if I can scroll over. Look, it's already doing it. It's coloring the cells, but I want it to be very specific. For the minimum value, I want it to be black. And for the maximum value, I want it to be white. Because that was what was being coded in our ultrasound program. And I'm going to hit done. Okay, close that. Now it's got some of the code in here, but what we're missing is a kidney stone. So I'm going to put another 1 up here. Oh, look, it coded that. And then a 0 there. Oh, look what's happening on the other side. I'm drawing with numbers. There's our kidney stone. And see what happened. When I put in that 3, it changed all this to gray because the maximum value is that brightness. Okay, and then the minimum value is 0, is black, and then sort of a medium value is that gray color. So let's put some more empty space in our kidney, and then a 1 here, and then let's close off our kidney. So I go to the top, I got a 0, and then there's the back side of my kidney. Hopefully not mine, because I don't have a kidney stone. At least I hope not. Okay, and then we can fill out the rest of our image. And then the same over here. Boom! Look at that! How beautiful. Okay, so I think I grabbed a little extra over here, but you get the idea. This is how we transform, how we encode. This process is called encoding. We get wave data and we turn it into an image. Okay, digitization and then encoding transforms information we get from waves into an actual picture. How cool is that? Well, if you think it's really cool, I'm glad. What I want you to do is try this with the data you've been given. Okay, write this program, try it with the data you've been given, and then I want you to create your own image. It could be anything, and you don't even have to use black and white. Okay, you can use red and green, or you could use the rainbow colors. I want to see some really pretty pictures here, you guys, of your own thing. Okay, so not a kidney stone necessarily, just draw me a nice picture with your waves, then have a partner try and decode it and use their program to write it. Even better is, if you want to make this resolution a little bit higher, you can increase the resolution by adding more lines and adding more depth. Okay, so you get a bigger image. Great. So give that a try. Awesome.